A warm welcome to all of you to our today's deep dive session of our Smart Cabinet Building Initiative Technology Meets Expertise. During our today's presentation, we want to leave the level of PowerPoint presentation and want to show to you how you can really create a digital twin and how you can make use of this information for automated and assisted manufacturing, including a live demonstration directly here in our headquarters of Weidmüller. First of all, some additional information. My name is Christian Dürme and I'm the head of the product management for automated cabinet building at Weidmüller. And today I have some colleagues of the different partner companies beside me, for example, Achim Stiener from Zucken for the digital engineering.
Welcome.
Hello, Achim. Additionally, the information that before we conduct this video session, everyone was tested regarding the coronavirus, and so we are allowed to do this session without any mask. Additionally, the information that before we will come to the use case of today's session, I want to give you some more background information regarding our Smart Cabinet Building Initiative. First of all, what's the starting point? Your challenges in your daily business were our reason to create the Smart Cabinet Building Initiative. Doesn't matter if we are talking about increased cost pressure, short-term changes, increased documentation, lack of skilled person. I think all of these challenges are really each day in your mind. And from our point of view, all of them are even increased during the last year based on the corona pandemic situation all over the world. From our point of view, the best way to overcome these challenges is to combine competence and know-how. And that is what we exactly do with our Smart Cabinet Building Initiative. Inside this initiative, we have Weidmüller for the industrial connectivity. We have Komax as the leading company for automated wire processing, Zucken for the digital engineering of cabinet building, as well as Armbruster Engineering for the assistance systems for manual production. What is your benefit from our initiative? Together with the product portfolio of all the partners, we can support the entire process from engineering to wiring. And exactly that we can see in this blue circle with the digital twin in the middle, where we also want to show you today how you can easily come to this digital twin. And then we make use out of this information, for example, for component assembly, component marking, wire processing, and even pre-wiring, cabinet assembly, and all the other steps around the circle. Additionally, the benefit for you is we want to offer you a huge basket. From our point of view, it doesn't make sense to really convince each customer to go directly in the way of fully automated systems. Our target is to show you the whole range, starting with manual solutions, going further with semi-automated as well as assisted solutions, and for sure ending with fully automated solutions. And it doesn't care if we are talking about wire processing, component assembly, component marking, wiring and pre-wiring, and for sure also in case of the digital integration, we want to look at your individual needs, and based on your needs, we want to create the right package for you. And based on that, I think it's time to hand over to Achim, because Achim wants to give you more insights in the use case for today. And additionally, one information from my side, I need to leave because I want to go directly over to the machines and we will see us later. See you.
Thank you, Christian, and a very warm welcome from my side as well. My name is Achim Stiener. I'm from Zucken, and I will show you a little bit what you can expect from the next 60 or 70 minutes. And we will start. I want to start to explain with this small cabinet. Gordon, please switch. Exactly. We all want to meet at the Hanover Fair. This was not possible, and so we try with this event to get you a nearly live impression of our solutions. And we all explain it on the next 60 minutes with this example. This is a cabinet with about 100 components of different types of components, different manufacturers. We have terminals, we have relays, and so on. We have with plugs, and we have different connection types, push-in and cage clamp and screw connections. We have about 50 wires in this example of 6 different combinations of cross-section and color. So it is a small but hopefully representative example for your daily work, as you know from your daily work. So this is our physical example, and switching back to our solutions. Today we have some more solutions, but today we want to focus to these steps because of reducing time, saving time. We cannot show everything, but I think these are the important steps. We start with E3 series, how easy it is to create a digital twin, because the digital twin is the base for all exporting necessary data for the full automated machines or the assisted workplaces and so on. And so this is the first step, how we create a digital twin. Then we will export the necessary data to the assembler and to the RailLaser and to the ELAM'a workplace to complete the terminal. After that, we show you how we can export very fast the necessary data for producing wires in 2 different ways. In a high-end solution on the Komax, Zeta or Omega machine, producing bundles in a sequence order. And on the Omega, we can also show you how they will be pre-wired on the machine. And another type of producing wires is the wire processing center. We show you also. And if we have done all the pre-production steps, then all the components and pre-assembled products meet at the assisted mounting plate assembly. And as well of this, we import or export some necessary data for this workplace. And there we have also a nice solution how the worker can assemble a cabinet without any paper in a very smooth and smart way. So in this, around about 70 minutes, we have included 2 small coffee breaks, so you can focus now completely on our presentation, and you have 2 possibilities to have a small phone call or an email check or something else in the coffee breaks. So let's start from the introduction to the doing. So if you are a cabinet manufacturer, and you will get, maybe the comfortable way is you get a fully complete predefined digital twin from your client with E3 panel, and then only you have to press the export tools and creating the data, the necessary data for all the machines. If you don't get such a nice digital twin, don't be worried. I can show you how fast and easy it is to create one from scratch. I want to start with an empty project, so you can see it. There are no devices, there are no components in, just 3 empty sheets, and this is really our starting point now. There are various possibilities how to get such a digital twin. As one example, I will start with a so-called template. I import an assembly of my mounting plate, and with the assembly, or with this template, all the necessary components are loaded. We have the mounting plate with the cable ducts and the rails all mounted, finished, so we can move them, or we can change them, we can delete, we can add. But this is if you have a typical template for such mounting plates, you can save them as a parts file and can import it very fast. So at this moment, we are possible to export all necessary data for mechanical production. We can export data for mounting plate drilling machines, and we can export for cutting machines for length cutting machines of cable ducts and mounting rails. So all the data is done. We know this is a one-to-one drawing, and we know exactly all the length and the mechanical data. Continuing with the import of the electrical components. In another example, I want to import this bill of material, these components from, for example, an Excel file. Hopefully you get this from your clients. So the minimum requirement is that we need the components, the article number of the products, and normally you should also get a device designation. Yeah? If you get those, we can import it, and you can see now the 90 additional parts are loaded. My tree is getting longer and longer, and in the same way we also can import, for example, a wire list. Also here the minimum requirement is a from to list. We need source and the destination pin. If you get from your customer or from something else the color and the cross section or a signal name or something else, that's fine. It's nice, all the better. The minimum is a source and a destination. So in my case, I'm lucky man, I have some additional information, I import it, and so now we have 46 wires imported, so they are also now in my tree, and now I have to place them. If you get some data coordinates in your bill of materials, how where the components are be placed, then we can do it also automatically, but typically you don't get the coordinates, so I will do it manually, and this is very fast. I switch to the panel unplaced tree. Here are all my components I have loaded in my project, and now I can start placing them by drag and drop. Yeah? And you can see it's easy. I can do this in 3D, or I can do this in, in 2D. It doesn't matter. I can do this with single components, or I can do this with a multi-select, like here, all the relays of the term series. I have automatically, you can see these pink marks where I can place them, so they switch automatically. I can't place it here, my connectors on the cable ducts or on other components, so this is not possible. So we have a lot of checks inside E3 that you can't do any mistakes. I can place all the terminals and so on. This case, so you can see it's a child's play how to, sorry, a little bit too fast, and maybe the U remote, And so I'm nearly finished. And you can see also the red airlines. These are the connections. Yeah? We know from our from tool list where we need some connections, and my E3 auto connect, if I start them, helps me to doing the auto connect in a shortest valid way. So we have now all our logical connections switched to physical connections. Now we know all the lengths, we know the cable duct fill degree, and all the other things. And now we are really nearly prepared for the next steps. Digital twin is finished. So I had to do some components, but you believe me that I can do it if I have 30 seconds more time. But I want to save this because now I export these two rails with all the components to assemble on the RailAssembler and on the RailLaser. So we export this, mounting rail 4 and mounting rail 5 to the Weidmuller configurator, starting automatically. Project is successfully created. Takes a few seconds. And now you can see, okay, I have imported exactly the mounting rail 4 and 5, exactly with all the components in the correct order, with the correct labeling, with the correct distances, like in my digital twin from E3. And now we can do some optimization. In this case, I rotate the marking text 90 degrees and do them bold so that they are a little bit smoother to read. And now I'm finished, and we can export this exactly to the RailAssembler and to the assisted workplace and to the RailLaser. And within this, I want to switch to the shop floor. And Christian, it's your time.
Welcome back directly out of our factory, where I want to present to you more details about our RailAssembler. But first of all, I think Achim already explained to you very nicely how we can come to the digital twin and how we can create all relevant information. So I would ask Luca to directly start with the production of the first DIN rail. Our RailAssembler is our economical answer for the automation of the process step of terminal block assembly. Our machine has overall 40 component magazines as well as 18 magazine places for pre-cutted DIN rails. Based on the individual order, the relevant pre-cutted DIN rail is selected, transported, and we are placing directly the first terminal blocks on the rail, which we can see right now in the camera. Maybe you see that the difference when you have a look at the component itself, because we are using our A-series terminal blocks as a so-called DL version, which have already pre-assembled blank markers on it to have even more efficiency increases later during the fully automated marking process itself. My idea is we take the time where the machine is assembling the fully equipped DIN rail, and I want to explain you some more technical details on the machine, and therefore I would like to ask Luca to come over to me as well as Victor to come over for showing our first small detail of the machine. The first detail, which is very relevant, is our universal component magazine. I said we want to design an economical solution for the automation of terminal block assembly, and one aspect there is our magazine. This magazine consists of a reduced DIN rail profile, and based on this DIN rail profile, we have several advantages. For example, this magazine type can handle different kind of contours. Luca, would you like to show to you? So it doesn't matter if you have small terminal blocks or even bigger ones, you can use the same type of a component magazine. And that is really an advantage compared to approaches where you have site guidance and a one-to-one relation between the component and the magazine type. You already saw that also during the filling process, no terminals can fall down or out. Also, the loading volume is extended to 200 terminals, 2.5 millimeter cross-section, so that we avoid open quantities and can directly put all components in one magazine. Then one additional small, from your point of view, maybe small point, but from our point of view, very important point is, at the end of each component magazine, we have there an area where you can put inside your individual marked and printed card with further information, maybe a picture of the components, maybe additional codes for your individual warehouse handling and so on. And also that is from our point of view a small advantage which really helps you during your daily business. Okay, so the machine is still operating. During that time again, I just want to show you the area where we can find these 40 component magazines. Here we have the area for these 18 pre-cutted DIN rails. The DIN rails can handle a length of 100 up to 1,200 millimeters. And if you have only the small ones, you can put several ones on the same position. So in the end, we are talking about 18 parking places where you can put up to 1,200 millimeters inside. And it's depending on your individual production order how many pieces you can put there. So the first DIN rail is produced. Maybe Luca can put it out of the machine and we will show it to you. It's just transported to the end. And you can see it's exactly the same specification as Achim designed just a few seconds ago. Then we have there is a second DIN rail configuration. Also there I would like ask Luca to directly start with the production, and we will go back in the area where the robot is assembly. Because we have several, sorry for the camera confusion, so in several DIN rails we have the topic of how we can handle components that aren't ready to robot, that aren't grabbable with a robot. In our approach, we give the information which components aren't able to handle to the robot. We also give the information to the assisted workplace of Armbruster. And this machine is ignoring these components which will be later assembled with the assisted workplace solution. So you can see at the beginning we have the free space where we can put later the missing components on, and also that we want to show you later during one live session. I think based on that, we understand the principle, we see how the machine is operating. We are talking there about time efficiency increase up to 60%, which coming most likely from the individual commissioning of components and all the other steps around. The mounting itself, we are realistic. Humans can do it in the same speed or even faster. But please have in mind, if you load up all magazines in the morning, we are talking about several hours without any manual interaction. And based on that, I would say, let's take time for a small copy or sending one or two emails. And during that short coffee break, you will see also a video where you see that our RailAssembler and our RailLaser could really be a friend also in your production. And don't be afraid, if you're missing the noise and the voice of the video, everything is right with you. We say, if you want to have the time for checking an email, it makes sense to don't have there too much music in the background. So see you later in the next area. Bye-bye.
All right, now we are at the component assembly, where we have the two pre-assembled terminal rails right from the RailAssembler, and we will finish them up here at the component assembly station. To do this, we need to scan the production order number, and then we will see step by step the generated work instructions that are coming right from the export file of the digital twin to show us where we have to place the components. We can see here that the cross connectors are assembled And with the ELAM system, we will check every step and guide the worker through the work instructions. We also are supported by a pick-by-light system. So the worker knows where he has to take the cross connectors out. He's confirming every step at the ELAM panel and is now going through the steps one by one. The first rail is ready, and now we take the second one. Here we have a little bit of a different
Yeah. Hello, I hope you can hear us now again. So we have some issues with the microphone, but we have a backup prepared. So welcome back, and I hope that you now can hear us again. Sorry for the missing explanation of Timo. We will compensate it later through our presentation, but now we want to continue with the topic of RailLaser printing. So Timo just showed you how we can assemble further components and accessories. We have now the assembled DIN rail that we already saw on the RailAssembler. And the good thing is, if we have the RailLaser there, the only thing which is still required for the automated marking processing is putting the DIN rail inside, fix it, and press the start button. Again, we have there all relevant information from the digital twin that Achim initially generated in E3 series and then hand over to the Weidmann configurator so that all information is understandable as well for our RailLaser. Our RailLaser can handle DIN rails with a length of 100 up to 1,200 millimeters. And the real difference is that before we are conducting the marking process, we have there an image processing system inside that is analyzing for each marker the real position, compares this position with the digital twin, and is conducting fully automated the required adjustment so that we can really be sure that we mark directly in the middle. And we are doing this from several sides so that we can also, for example, reach markers that are in a gap between bigger components. And you can see here in the screen that, for example, for the end brackets, we are still analyzing two positions. And based on that, we even analyze the angle compared to the DIN rail. Stefan is showing you now an example how we can do their correction. And we also can show you the real information that is analyzed by the image processing. For example, in this case, 90.97 degree is the angle of the marker relatively to the DIN rail. In the background, the last steps of the image processing analyzing are conducted, and the machine will start then with the layout generation, where we are analyzing which markers can directly be reached without any mechanical movement. And now you can see they are directly inside the machine with a webcam, and you can see that the laser marking itself is quite fast. And one additional benefit is, based on our laser source, you can use our standard marking material. So you don't need to have any special marker material for the process step of the automated marking. You can use the same marker also like for our print jet. For example, if you need to print anything in color, I think it makes it much easier for you. So the first marking process of our first DIN rail is nearly already at the final stage. Just the last markings, door is opening, and there we have the final DIN rail, which is Stefan now showing to you directly in the camera. And you can see there that we have a very sharp contour and really precise marking all around the DIN rail. So that was just our first example. I want to take the time and show you a little bit more the universality of the machine. So which kind of different terminals we can handle. We can handle for sure big ones, small ones, and exactly also this kind of gaps or deeper areas we can also reach with our image processing inside. But we not only can mark terminals, we can also mark, for example, over voltage protection components. Exactly this one that a few seconds over Timo and Malte showed us at the assisted workplace of Armbruster Engineering. So Stefan is also putting the DIN rail inside, press the start button again. We show also the operator a preview so that it's easy for him to put the DIN rail inside in the right position. And then again, our procedure with the image processing is starting and analyzing. One additional benefit is that also the marking itself has some advantages because it's very robust and not only on the roof. We maybe can show you some more examples and a little bit about the topic of time efficiency increase based on the DIN rail that we have put inside a second RailLaser. This DIN rail is 1,200 millimeters long. The manual production time for this DIN rail is roughly 60 minutes for finding the right markers, printing the markers, snapping them on, and have a final inspection. With the RailLaser, we are only talking about 6 or 7 minutes for the full automated marking process. We have also some more examples of different contours, different configurations, different sizes that really shows universality of the RailLaser. Maybe you are asking, okay, nice, we have there the A series DL version, but what is if I need a component and want to mark it with the RailLaser where Weitmüllers don't or is not offering a DL version? Then my answer to you is, then you can also put manually the blank markers on it. And even then we are talking about time savings up to 60%. For sure, compared to the 19%, it's a huge difference, but I think even the 60% is really a benefit. And if you maybe remember the video that we showed during the first coffee break, I think you also see there that we are using our image processing for checking if the assembly, especially of the markers on the terminals, is done in the right way. And we are guiding the operator if something is wrong. And based on that, we have more or less a dynamic quality inspection inside. And that is also, I think, a big benefit for you as well. Okay, so that's just a short explanation regarding the RailLaser. My proposal is that based on the fact that you don't hear what Timo is saying, I think we just repeat the session directly at the assisted workplace, because I think it's also a very interesting thing for you to understand it. I will hand over the headset Timo again, and then.
Thank you very much, Christian. So yeah, as I was saying, this is the component assembly where we just get the two terminal rails that we have from the RailAssembler, and they came pre-assembled, and we are finishing them up now here. And to do this, we are starting with scanning the production order number, and now the ELAM system is showing the worker dynamically generated via the digital twin exactly what steps are need to do, so we can finish up the terminal rail. We are also supported by a projection system, so we see directly on the table where the components have to be placed. And the worker now goes step by step through the completion of the terminal rail and is confirming it on the ELAM panel, step by step. And another component, we also have are supported by our electronic screwdriver. So we are monitoring the screw process in the ELAM system and documenting the angle and torque, placing the markers, confirming it again. Now we have some cross connectors that needs to be placed. The worker can lay it down on the table and see right in front of him via the projection what cross connector legs he has to pull out, confirming it, placing it. It's also shown via the pick by light system where he has to take the cross connectors out. And the next one, and the last one, confirming it. And now the terminal rail is completely assembled. All right. Now we go back to the studio.
Hello and welcome from my side. My name is Blair, Hans-Peter Blair. I'm working for Suken more than 20 years, and I will give you some information about the export to Komax, how we can export data from our digital twin, as you can see here, to the Komax machine, to pre-manufacture wires and making sequence bundles for wires, and also sending information for block loading. So we are in the process here. We did with the RailAssembler, we did the terminal rows and so on. We did the marking, and now we are sending the information to the Komax Zeta or Komax Omega. Let's switch over to E3 series. Here we have E3 series. Here we have E3 panel, the 3D panel layout. And let's have a closer look to this panel layout. Here you can see some wires connected to a connector, connected to a terminal strip. And when I hit the wire, I get information about the wire type, the wire color, cross-section, and of course about the wire length. So this information and also the information about the terminals for the block loading, we now want to send to the Komax machine. Therefore, we have an export. As you can see here, we export this information now to the Komax machine. And you can see we have exported 46 wires. And these wires, they are collected into 6 bundles. So there are a lot of checks. There is a configuration file which gives the information which component we want to export to the Komax machine, and also we will check a lot of things depending on the configuration of the Komax machine itself, which wire is available, and so on. And as you can see, we have produced a CSV file. That's the file we will send later to the Komax machine. Let's have a look to this file, and we start the Windows Explorer. We want to have a look at this file. So this is the file we have created, and you can see a lot of columns, and to make sure that you can see what's inside. So we are exporting the information about the article name of the wire type, the wire color, Then the wire length, of course, it's very important. We have the stripping lengths on both sides. We have the ferrules on both sides, and we have the information about the marking. So this is target 1, this is target 2, and then we have additional information about the text, the font, and so on. So this information can be used one-to-one on the Komax Omega, and so you can see how this works. We will switch to Komax in the production hall. Thank you.
Okay, thank you, Hans-Peter, for preparing the data. We will now witness how we turn this digital twin into a physical product onto this Zeta 630 from Komax. My name is Cornel Durer. I'm a market segment manager at Komax. The company Komax provides innovative solutions for the fully automated wire processing since 1975. The data Hans-Peter just prepared is first converted in a simple converter tool to match the machine format and then loaded directly onto the machine. So let's zoom in to the user interface now. Please switch the camera. Okay, I hope, yes, now we can see the user interface. Here we have the messages which arrived, so we can see there are 6 sequences ready. So these are the 6 sequences designed in the CAD. I can just select the first one, load it to the machine, and start now the production for the whole sequence. To learn more about how the machine works, we will move around to the wire selector. The wire selector holds up to 36 wires of different colors and sizes. It covers cross sections in a range of 0.22 to 6 square millimeters, or AWG 24 to 10. A powerful belt drive will then pull in the wires, and its length is accurately measured using a length measurement encoder. In the next step, the wires can be marked using an inkjet, where we can mark the wires with both black and white ink to achieve the best contrast for your free configurable text and markings. In the next step, the wires are then cut and stripped to the expected length. We can now either just leave it half stripped, so we can process it manually later on, or we can attach, for example, ferrules with this ferrule module, which holds 5 different ferrules in a section range of 0.5 to 2.5 square millimeters. Optionally, we can mount many different other modules for different wire end processing to the machine. For example, another ferrule module for 4 or 6 square millimeters, crimp modules, ultrasonic compacting, resistance welding, or tube marking. Tube marking provides an alternative marking besides the inkjet writing, so we can mark directly shrinkable or non-shrinkable tubes to have a perfect contrast for your marking. These modules can be directly attached to the machine. Here we have a Zeta 630, which holds 2 modules. We have other models which hold either 5, 8, or up to 13 different modules. At the end of the process, we have the bundler, which stitches the wires together, either in sequences or bundles, so you have it nicely sorted in the end. So, let's have a look at the result now. Here we can see now such a sequence. We have the marking on the wires, and we have exactly the correct sequence for a component in your electrical cabinet. So attaching it, mounting it in the cabinet is very simple, very straightforward, without lots of documentation. And this whole process will save you up to 50% compared to a fully manual wire processing. As an alternative solution to the sequences, we can as well attach the wires directly to your casing, your components, and therefore we can use a machine called Omega, which we will now see in a video. Please start the video. So the first part of this machine works exactly the same as the Zeta machine we just saw. The wires are loaded, cut, stripped, and then with different modules, the wire end processing is done. But now we'll have a sequencer. The wires get visually checked, oriented, and then directly placed into your housings. The machine has two sections. In one section, the wires are attached, and the other section, an operator can safely remove the whole modules from the machine and attach the new components. So this is the final result. So you see there's a fully automated process, and this is now how we can turn your data directly into a physical product with a minimum manual workload. That's everything I want to show you. Thanks a lot for your attention, and I'm giving back to my colleagues from Zucken.
So, welcome back here in the studio. Now, coming from the impressing machines back to hopefully impressing software. The next step in our presentation is now showing the export to the assisted mounting plate assembly. We have seen in the last 40 minutes or 50 minutes the pre-production of all the necessary assemblies and components and wire sets and so on. And now we want to assemble them to a complete cabinet. And we have also a small smart tool to create these work instructions directly out of the digital twin. And to explain this, it makes sense to switch to my panel placed tree. So E3 series has a hierarchical structure. So E3 knows which component is placed on which other component. So if I have here my mounting plate, it's now in pink. We see, okay, we have a lot of cable ducts, we have some mounting rails and so on placed directly on this mounting plate. And on the mounting rail 1, for example, we have some other components like these terminals and so on, and mounting 3. So we have a lot of exactly this hierarchical structure. And we use this to export this to our ELAMA system. To handle pre-assembled assemblies or components, it's very easy. We only have to select them and say, okay, you are pre-assembled. Then the whole bunch is handled en bloc. And we have a small simulation tool to check these just before exporting. We have to start by a mounting plate and then start the, sorry, stop, we start here. And the rule is now we start from the mounting plate, and at the first one it's done with the rails. The first rail is the rail 1 on the top left. This is a pre-assembled rail, so we also get all the terminals on it. Next one is the rail 2, it's empty, rail 3 is empty, 4 is pre-produced as we have seen on the Komax Omega machine, and so on. After the rails, the cable ducts are being placed, normally always from the top left to the bottom right, and then the components who are on the mounting rails are placed. Also the same from top left to bottom right, step by step, and so on. And so this would be the exported working instructions for the ELAM. We see, okay, now we have 104 components assembled, and creating this file, it's a child's play. It's just one click, and now we have an XML file we can read one-to-one into the ELAM system. This is a very easy algorithm, but I think it's a very comfortable algorithm of how the sequence is. If you want to change the sequence, it's very easy also in ELAM to say, okay, I want to assemble mounting rail 3 before 2. Yeah, so, but important is that you get everything in this file, all the components in the right order with some additional informations, maybe if hyperlinks to additional documentation and so on. It's all exported from E3, and you have less work in the shop floor to pre-produce such working instructions. And with this export, I will hand over to Timo, but just before we do our second coffee break, and showing also you a small video. It is always without the tone, and we see you in more or less 5 minutes. So hopefully you came back to us.
All right. So now with the export file from the E3 series, we can now go to the cabinet assembly for the mounting plate. And via the export file, we will now assemble the mounting plate via the ELAM system. It's the same procedure. We have the digital twin file, and we are dynamically generating the work instructions as shown here. And we are going step by step through the assembly process. First thing is to put the label on. Next steps are the cable ducts. And the specialty here is that we are projecting everything right on the mounting plate, so the worker can directly see where he has to place the parts. At first, the cable ducts. And after placing the first cable duct, he confirms it again in the ELAM system and is now taking the second one out of the pick by light supported area and placing the second one here, also supported via projection directly on the mounting plate, confirms it in the ELAM system. And now we have a serialized component that we are tracking in the ELAM system via a scan. So now he scans it. The system confirms that the scan is valid. And now he places it directly on the mounting plate where the projection is showing it. And now we have the pre-assembled components, the pre-assembled terminal rails that he's placing on the mounting plate using the screws. So you can have already assembled components as well, and using it for the mounting plate assembly. Confirms that part again. And now he has to place the already wired part. And now to the second terminal rail that has already been assembled. You can see on the ELAM'a panel that we have a list of the components that he has to assemble right now. You can see 3 of them are already marked in green, so they are already assembled. And he has 3 plug-in connectors to do. The first one is now to be assembled. And here we have a crosshair to show the worker exactly where he has to connect the plug-in connectors on the component itself. Confirms it again. And the last one also confirms it. Everything is documented in the ELAM'a system. And now we are coming from the Komax wires that we have to place. In this case, we are using the wiring cockpit. So the worker can see where he has to wire the wires. And also confirms it right in the wiring cockpit. And so he takes every wire from the Komax and assemble them. And now we are switching to the VPC.
Okay, now back from the studio, it's me again, and I will show you another step in the process. So we can export wiring information to the WPC. As you can see it here, from the digital twin we have the connection information, and we also can export this to the wiring processing center, and I will show you how this will happen. So we are in the 3 series now, and you can see we have a wiring diagram which has electrical and logical connections. When I hit the connection, I will get my tooltip, which shows me the signal, the wire type, the cross section, the color of the wire, and of course, what's very important, the length of the wire. So when we export wires, you see here's another wire, here's another wire, and when I jump to my panel layout, you can see this wire here in the 3D layout as well, and from this information we get the exact length. So we can export the wire information only from the wiring diagram if we have some lengths here already. Otherwise we can export information from the panel layout, and normally our customers, they do this in combination, so they have the object orientation with the direct link between the wiring diagram and the cabinet layout. So we can export this information now. You can see it here. I have a button, Weidmuller WPC, and I will export this information now. As you can see, we can also export dynamic cables, so let's do this. Yes, we do. And now you should know the WPC can handle wire cross sections minimum 0.5 and maximum 2.5. So it has generated this list. So we will save this list for the WPC. Yes, we save this one. And here you can see in the messages, there were some checks done. I told you that we have a cross section, which is 0.5 to 2.5. And here I have a wire which has only 0.35. This will not be possible. And also we can check, for example, if the wire has a length or not. So here the same wire we have has no wire length. And also we can check if there is the wire color. For example, here I have a wire which has no wire color, and so I will need this information, and therefore this will be checked. So I can send this information to the WPC, and let's have a look how they will handle this data. And so we switch into the shop floor and we will see what they are doing with this data. Thank you.
Yeah, thank you for the data package, and also hello and welcome from my side. My name is Lars. I'm working for Whitemiller since 10 years, and I'm responsible product manager for our automatic machines, including the Wire Processing Center, or short-term WPC. So standalone machines we have in the market since more than 40 years. And what is new with the WPC, I'm going to show you right now. So we have equipped those machines with state-of-the-art interfaces and a certain protocol so that they're able to communicate with one another. The WPC is a mobile workshop wagon, so you can place this anywhere in the production site. Down the desk you have a cabinet with an IoT device, so industrial PC, that is running the software, illustrating the worker what to do, and also steering the machines. So key thing is, so you will open the processing list that was just transmitted by the colleagues from Suken E3. So here you have one-to-one the list that was transmitted. When speaking about flexibility, for example, you could choose that maybe the printing should be done separately so that you skip the printer out of the communication process. When you want to get started, so in total, we still speak about the semi-automatic approach. So we have different kind of cross-sections in here. Right now, 6 pages with different jobs, could be 100, could be thousands. So you need to physically install one of the wires in the cutting machine. So in this case, we have the black 2.5. Now you proceed to set the cross-section to the 2.5s, actually the black ones, accept the filter settings, and then you have reduced the cutting jobs only to the 2.5 black wires. Now you can easily say, okay, I want to get started. Before it starts, you get a short executive summary on what will be done in the next second. So if you start the process, the magic runs. The cutting machine is cutting the cable 400 millimeters. In parallel, the printer is getting the data, and also the crimping machine is adjusted to the right cross-section. So now we simply place markers on it. When speaking about the markers, we have different kind of variants, so whatever fits for your application, it can be installed on the printer. Now nothing is happening because we're waiting for the worker to bring the cable into the crimping unit. So first crimp, second crimp. Now one piece flow ready, next job starts automatically. And this is when we speak about process safety also. So the software is telling on what to do. So 2.5 cross-section. The worker is not able to change to any other cross-section. What is actually possible, if you touch on purpose and activate the standalone function, then we are switching to offline modus. For example, if another worker is coming, wants to process very quickly a bunch of cables, 50 pieces, so you can easily switch to the other cross-section and finish those crimps. Afterwards, switching back to systems approach, we are in online modus, and the other worker can go ahead with processing. This is very important when speaking about process safety. So the software is the brain of the system, and it is not a must-have that a specialist needs to run on the system. Could be also other people, so that everybody in the company can focus on value-adding activities. What is also possible when we speak about on how to get data here on the job. So one very smart way we have seen over Suken E3, you can also bring in jobs here very easily over the quick start function. So a neutral conductor is being shown, and you can easily put something on the spots here, and so choose a cross section given in a certain length, number of pieces, let's say 6. Another cable color. Maybe on the second side we don't know the concrete lengths, so we start like this. Before it starts, actually, this will show right now the result on how the finished cable should look like. And if we would now start the job again, the magic would run just once again. The WPC approach will be developed further on. So we speak about regular coming software packages and also new hardware features. So one change will be in very short term will be a new cutting machine where we also have a multiple feeding unit. This is not yet in, but I will show you a short video of the standalone function implemented in the WPC approach will be roughly in June. Now please switch to the video. So in a standalone function, we have launched this officially at the Digital Hanover Fair. So here, this is a very compact cutting machine with a 5-inch color touch display, and on the left side implemented multiple feeding unit. So here you can easily implement up to 12 wires. What you need to do, so learn or teach the software in which slot you have which particular wire. So this is a one-time effort at the very beginning, and afterwards in the quick start function you can easily then bring in different cutting jobs. You will see on how the changing of cross sections will run. So in the quick start function, very easily simply adding a job, so 250 millimeters, 3 pieces, and then you could choose the according slot where you have the right cable inside. Now it's bring into position and we cut the 3 wires 250 millimeters. Next you would simply go back to quick start. You could change the cutting data if it's the same length, just another cable needed, so you simply go for the other slot. The machine is bringing the new cable into position and the other cross section will be cutted very easily. This is for sure bringing the WPC to an even more flexible approach. And again, this will come in June. And now I will give back to the colleagues.
Okay, so now one of the last steps on the mounting plate assembly is to connect the wires that came from the VPC, and the worker is just wiring that. And you also see at the wiring cockpit again, just like for the Komax wires, where he has to place them, and also have to confirm it directly in the wiring cockpit. Now the product is being photographed, and the assembly is done here. And now I give it back to the studio.
Yes, welcome back. Hope you enjoyed our small round trip. So we started with the digital configuration of the digital twin in E3 series. We then transmitted the data to the Webinar configurator, so that's also understandable for the RailAssembler assisted terminal block assembly as well as the RailLaser. And then we showed how we can bring the data information over to Komax machine for the wire processing or even pre-wiring. And we used all information for putting the kits together for the assisted mounting plate assembly, as well as for some last wires which are produced with the wire processing center. So first of all, sorry that we are a little bit over time, but I think it was good to repeat the session with the assisted terminal block assembly. Hope you enjoyed the trip. Sorry also for some technical inconvenience due to our session, but I think for us it was really the key that you get the live feeling also over in your office. And from our point of view, we hope that you understand that based on the solution of the Smart Cabinet Building Initiative, you are able to produce faster, more flexible and more economical, more or less lot size independent. So we discussed several times the dynamically interpretation of the work instructions. We showed how easily we can come to the digital twin and so on. So from our point of view, it's also a topic for lot size 1 as well. We showed you integrated solution from engineering to wiring from one hand. We showed manual tools, assisted solutions up to fully automated solutions. And you see that all of these solutions are already in daily use and are available. And based on that, we are looking forward for your feedback, for personal discussion. We are hoping that we can meet each other again personally. But first of all, we hope that you enjoyed our session. So take care.
See you.
Bye-bye.